Hello, good afternoon. Welcome to the Makerspace. My name's Dan Berteris. I'm the Executive Director for Experiential Learning on campus. So if you don't know me, my job basically is to promote hands-on learning, look over all of our facilities, our clubs, everyone that does hands-on learning on campus. So welcome to the Makerspace, and what I want to encourage you guys to do is if you have something you want to build, if you have a club you want to start, we have 3 brand new clubs that are starting this semester. So they came and talked to me. One of them, actually, our guest will like is a rocketry club. We have a rocketry club starting. So spend some time in the Makerspace, think about things you want to build and learn to enrich your education here at NJIT. And then come talk to me about it, and we'll see if we can make it happen for you. A couple things I want to bring your attention to in the Makerspace is we have a couple new courses running that are starting for the first time. So this semester we have a CNC routing course. Next semester that will run again, there'll be 4 sections of that teaches you to use CNC routers, CAD, CAM. They're 7-week-long courses, so you can take them 1 credit, you can take them quickly and learn those skills. We also have a new welding course, which is also running for the first time this semester. There'll be 6 sections of that in the spring. So think about learning to weld is a really cool skill. And then a first run of a course called Metrology, Introduction to Metrology. So if you're not aware of what metrology is, it's the science of measurement. So we have a really seasoned metrology engineer who is designing that course right now and going to run 4 sections of that in the spring. So if you want to learn how to do precision measurement, you want to learn how the world actually works, measurement is the foundation of everything that is built. So really cool skills to learn, so consider taking those. Those are all under the ENGR course heading, so they're all ENGR 22 something. So look for those course codes when registration opens in a few weeks. So a little bit about our guest today, Mr. Joe Oliveira. He is a graduate of NJIT, and he was one of our first Makerspace student employees here. So he worked for us for about 3 years, started shortly after we opened. And he was tasked with building out our wood shop. So if you've been in our wood shop, a lot of the beautiful furniture and mounting systems and stuff that you see in there, Joe built and designed. And then he worked here for many years and then graduated with a degree in industrial design. And then he took a job at Hacks, which is a product accelerator type. He'll talk about it during his presentation, and they're in downtown Newark, and there he manages their machine shop and their prototype shops, and he helps the clients accelerate their production and learn how to prototype things as they are a startup company. So let's have a big round of applause for Joe.
Good morning, everybody. Oh, no, it's afternoon. So thanks again, Dan, and thank you so much for NJIT for hosting me here today as a representative of SOSV and Hacks. So as Dan said, my name is Joe Oliveira. That's me, and that giant sign I built, which is a lot of fun. My name is Joe. I am a industrial designer who works as an engineer, which is kind of funny. But key points, I'm a New Jersey native, born and raised, graduated in 2022. As Dan said, I was the first woodshop manager, and last year I was elected to the New Jersey Innovate 100, which is the top 100 innovators in the state of New Jersey. That happens every year. So a little bit about me. I make a lot of stuff. It's been a lifelong passion. It's been something I've done ever since I can remember. A lot of stuff that I've done actually really got accelerated here at NJIT, specifically in the Makerspace, because of the amazing facilities that we have here. So, I've done a little bit of everything from some heavy drone work, some combat robotics. I love building birdhouses. If you want a overbuilt birdhouse, I have plans. That was my COVID series. During COVID, I locked myself in the wood shop for a couple of months, and I just built the most overbuilt birdhouses possible. It was a little too much, a little bit of cabin fever going on. So the wood shop here is really where I started. That is one of my coworkers from back in the day. We built basically all of the furniture that's in the wood shop, and we built it from basically nothing. As Dan said, they hired me, and I came in, and the floor was basically flat. Some of the machines were put in place, and they said, fill in the rest, which was kind of exciting. And it really actually set me up for my career going forward. So speaking of my career, I work at a company called SOSV. So SOSV is a venture capital firm that invests in new tech startups focusing on robotics, climate tech, and biotech. We're based out of Princeton, New Jersey, with offices all over the world. And what we do specifically is we accelerate new tech startups. So startups will come to us with an idea, with a MVP, with a prototype, and then our investment committee will look at them and they'll decide whether or not they want to enroll them in one of our 2 programs. We got 2 programs. One of them, do I go here? No, that's the next slide. So there's 2 programs. One of them is IndieBio, which is our biology and life sciences division, and the one that I work for is HACS, which is our hard tech division. The way we differentiate it, if you have what a company makes and you drop it and it hits your foot, it's us, it's HACS. If it doesn't, it's IndieBio. So to date, HACS itself has invested in over 1,000 startups. I'm going to talk about 3 of them a little bit later in the presentation today. I know for a fact one of them you all know, because you're all here, and 2 of them you won't. But these are 2 really amazing new and emerging startups that you should want to be on the lookout for. One of the things that HACS does better than anybody else, oh my God, what happened? What I was saying. We're located downtown in Newark, just on the corner of Raymond Boulevard and Broad Street. So you're in the heart of downtown. We're really close to New York City. And you wouldn't know it, but there's a 35,000 square foot prototyping, manufacturing, and chemistry facility 10 stories up in the heart of downtown. That's where some of the most innovative companies today are actually working just down the street. And it's really exciting. So normally our cadence is the company will come in, they'll stay with us for about 6 months to a year, and through that time, they'll work with myself and the rest of our engineering team on advancing their prototypes, building their processes, scaling for manufacturing, finding vendors to work with, and ultimately also working with our business development team on finding those addressable markets, finding their business plan, nailing it down, and then actually at the end of about 6 months to a year, we put them into a room with about $10 billion worth of investor capital, and we say, you have 2 minutes, pitch your heart out. That's our 2-minute pitch. So we drill them on how to give a good presentation, and then they have 2 minutes basically in front of, I think last year we had 185 different institutions and investors come to our 2-day event to basically try and secure that next round of seed funding or series funding for them. So one thing specifically that hard tech companies have is hard tech is hard. I mean, it's in the name. But software companies alone are not going to solve the world's problems we have today. And the reason being, a lot of great innovation can happen in the computers because, to start a software company, you really just need a laptop and an AWS account. To do anything related to hard tech, the cheapest thing you can get is a 3D printer, and that starts at about, $500 for a halfway decent one, let alone the $1 million 5-axis CNC machine that Dan will not let me take home in my truck as much as I want to. But if you're a brand new startup company, you maybe have $50, $60, $100,000 of startup capital, and you can't afford any of these machines. You can't afford the technology that you need to actually produce what you make. So that's where HACS comes in. Oop, there we go. So our founders are encouraged to prototype quick, often, and with a purpose. And the way we do that is we provide them the facilities. So as part of our investment, they will come, as I said, co-locate with us, and we supply the facilities, the equipment, the know-how, and the people to do it. Now, my industrial design teacher is here in the audience today. Jose, yeah, it's you. I think you'll recognize this cycle. This is the industrial design cycle. This is basically how HACS runs its engineering program. One of the most important things is you see that it's a loop. It's not linear. One of the things that happens is in new startup companies, they will basically find the problem, run straight at it, try and address it, and keep going to the end until they have a solution, they'll call it, and call it done. They don't go back and reevaluate. So basically, come on, oh, I can't see it. So the design iteration loop is really important because it allows you to refine your product and actually discuss whether or not your solution is actually solving the problem. Now, this is happening in parallel with our business development. So we have our business development team that is working with them and doing a similar version of this. They're doing customer discovery, they're doing manufacturing analysis, they're doing all the things you need to do for capital development while we're innovating and iterating in an engineering capacity. So I keep talking about the team. The team itself is about 40 industry professionals. We have 10 staff engineers, which I'm one of them. We're spread across 3 different locations. We're spread in Newark, New Jersey, Pune, India, and Shenzhen, China. And the 3 sites each have a different style to them. Newark, we're focused on the early stage prototypes and final integration of systems. Pune, India is geared more towards the heavy prototyping, FEA, CFD, heavy engineering, more longer term prototyping processes. And Shenzhen is our sourcing powerhouse. We have a lot of products that come out of Shenzhen. With the current, tariff rates, we're looking at other countries and other suppliers because, startup companies don't have money. They're all broke. And they need to find new sources of the parts and pieces that they need. But that constellation of the 3 different sites really allows us to focus on what each site is really geared more towards. So what does prototyping look in the startup world? I keep talking about prototyping. Anyone want to take a guess at what a high-level new engineering prototyping company looks like? Just one person, throw a hand up, doesn't matter. No? Go for it. Yeah, you'd think, they're new, they're a startup company, they got a bunch of money from an investor, they're gonna start working with metal, they're gonna start working with some heavy plastics, they're gonna start, right into CAD and CAM. No, you start with Legos. We basically tell everybody, when you start any engineering process, this may seem like a toy, but this is one of the best ways to get ideas out as fast as humanly possible. We got basically a dragon's hoard of Legos at the office. And the thing we do is we use these not necessarily to define the exact final solution, but to iterate through the idea. You may find that you have an element of your engineering solution that is really complicated, but if you can make it work with Lego, it's a lot easier than you think. So it's not uncommon to go into one of our office spaces and see 3 or 4 seasoned engineers with Legos scattered all over the table because they're working out a new mechanism or a new simplified system. The other thing that the Lego process does, it forces you to try and simplify all of your actions. It tries to break down complex motions into simple, discrete actions that ultimately are much easier to innovate and much easier to prototype in the real world. So, as you can see on the right-hand side, this is a water block. This is one of the parts that a company came in. Their name is Mimic Systems. They are a Peltier electric air conditioning system. They basically have designed a new way of doing air conditioning where there's no refrigerant, there's no compressed gases, it's all done through electric and water. So this, the main part of it is the heat sink that transmits the heat energy from the inside to the water and dumps it outside. Anyone that's done any machining looks at this part and says, how in the name of God did you make it? Because those are machined fins. Those fins are 12.5 times the diameter of the tool that needed to be cut into it. So that one part took me 26 hours to machine, one piece. And there's 4 of them in each module. So what we did was we machined one part because we needed to prove that it was insane. Because the founder didn't believe me, so I had to show him that it was a little bit hard to make. So we took that part and we sent it to 10 different manufacturers in the U.S. because they needed to have it be a U.S.-based company, U.S.-based part. 7 of them turned me down because they didn't want to deal with it. One of them quoted $5,000 a part. The other one quoted $7,500 a part. And the third one said, I'll give it to you for $4,000, but you got to buy 50 of them, because he's not going to tool up a machine to do that part ever again. So what we did was we took our engineering team and we said, we need about 2 or 3 weeks to redesign this. And we locked ourselves in a proverbial room. And over the course of 2 or 3 weeks, we came up with our first new version of this that used a different form of manufacturing. I actually brought the parts over here, so at the end, if you want to look at them, you can see them. We introduced the company to a form of manufacturing called skiving, which is you're physically peeling the pieces of metal off and creating very thin heat sinks instead of doing cast fins or extrusion-based fins or machined fins. And that little idea gave them the impetus to keep refining that process. So over the course of about 2 months, once we did that first prototype, we ended at this one on the other end. Now that part is currently in production for their system. And we went from about a $7,500 part down to a $75 part. So we basically, we cut so much money out of that one single line item for that one part that took the company from dead in the water to now they are actually commercially viable. They've got 5 units currently running, and they actually just signed a contract with a building in Brooklyn to do a 75 unit pilot, which is really, really insane. Now, if you had taken all of the parts and pieces that we made in-house, because between these two, there's about 4 major revisions and then 6 or 7 subparts for each revision. If you took that and on a normal 2 to 4 week lead time from your average CNC machine shop in the United States, you're looking at about 2 years worth of time between that part and a finished part. We did that in 2 months. So, like I said, these startup companies at this early stage, they don't have a lot of time and they don't have a lot of money to burn. Some companies are literally operating with 6 months worth of cash on hand. So 2 weeks for a part is criminal for them. They can't iterate fast enough. There we go. So we not only make the parts for the companies, but we also make a lot of testing apparatuses for them. So the one on the right is actually an explosion-proof box that we made for a company. Because there was an explosion in the office, somebody was doing pressure testing on a pipeline coating robot, and thankfully no one was hurt, but a pipe imploded on us. After that, we did a safety review, and I designed and built this explosion-proof box that's got double layers of polycarbonate that can basically take a small rifle round in terms of shrapnel and keep it all contained inside. And on the left-hand side, that is what we call our power walls. One of the problems with being in an old department store building on the 10th floor is that you don't exactly have access to high voltage electricity to run robot arms or vacuum pumps. So what I designed was I created, using some EcoFlow batteries, I basically made a small power grid that's on a cart that you can wheel this anywhere in the shop, and you have 240 volt, 30 amp service wherever you want. And you just charge it up overnight, and you have 12 hours of runtime during the day. So the whole assembly cost about $5,000 because the batteries are really expensive. I had an electrician quote me $35,000 to put a panel in and run the electrical lines. So $5,000. We may be a venture capital fund that just closed a $306 million round of investable money, but we want to save money where we can. We don't want to be wasteful. Again, these are just some examples of the stuff that we do for the companies on a daily basis. And we also do other things for them. This rather precarious situation where we're using a pallet stacker to lift up a giant crate is there's a small reactor in there that we're shipping across the U.S. to a team, and we needed to weigh it, and we didn't really have a good way of picking it up and putting it on a scale, so we got a crane scale, and myself and 2 other guys basically weighed it from the forklift, so we actually could get a weight for shipment. And then, you know, I may be the workshop manager, but I'm kind of the de facto guy that goes and fixes everything. So that's me inside of our $2 million air conditioning unit fixing it with a vacuum. And it was 110 degrees outside, so it was not fun turning off the air conditioning. And there's so many little parts and pieces that I make throughout the day. It's really hard to, you know, I could probably talk for hours just about all the bits and pieces that we make. But the nature of this organization that I work for is that we're always trying to innovate and solve the problems for the teams as fast as possible. Like I have on my desk a pitch counter because I sit right next to my CNC machines in the middle of the workshop. I have a pitch counter that every day when somebody comes up to me and asks a question, I advance it 1. The record is 46. So 46 people come up to me every day and ask questions. You know, it could be something as simple as like, what do you think about this screw or this screw for this application? Or we have, you know, a fundamental problem with our product and we need some guidance on that. But the access to the knowledge, not just my knowledge, but the rest of the team, is something that's really that the founders specifically really appreciate. Because you know, if you had a engineering firm that you were contracting with to do some contract work, you might have to wait 1 or 2 or 3 days for an employee to even just get back to you on your email, let alone get the right answer. Some companies will come up to me 5 times a day. Some companies will come up to me once a month, and whatever they need from our entire team. That's why we're here, and that's why the companies choose to make the investment with us. So now, we pride ourselves on beating most of the manufacturing processes that are local to us in terms of speed. You know, so a part that would take 2 or 3 weeks for somebody to get back, we try and do in 2 or 3 days. The record that I have is about 3.5 hours from somebody made a sketch on a napkin for a small part that we needed to make. We CAD'd it up, machined it, and handed it to them in 3.5 hours. It was a little sketchy, but because we were trying to go so fast, because they had a delivery date that they needed to make. But we have the facilities to do very quick parts and pieces. And again, these are just some smaller bits and pieces. We do a lot of bioreactors. So the one on the upper right-hand side, left-hand side, sorry. The upper left-hand side, that is a bioreactor for a company called Carbon Bridge. They do live cell culture methane production. And that's that's a test model that we made for them before we sent it out to have it made in stainless steel. We don't make all the parts in-house, but what we'll do is we'll prototype the parts in terms of form and function, and then we will hand them off to the people that have the bigger machines that can work a little faster. You know, we cut gears for a company that broke 4 of them in their drivetrain, and they had another delivery date they needed to make. I have a tendency to fix things in our shop that aren't exactly nice, so that's a little hand jog wheel that we made. And then I make a bunch of these for people that visit. These are our challenge coins that we make. I have a really big one over here, but the normal ones are pretty small. And they're really quite something fun. So now I'm going to talk about 3 companies that you know. So the first one is Formlabs. Formlabs actually got their start with hacks. Many years ago in Shenzhen, where hacks first had its first office, the Formlabs founders actually went to hacks and created, what is going on? There we go. And created everything before the Form 1. So all of these different versions that you see, these were Formlabs printers before the Form 1 on the very end. And you can see they started off with just some 80-20 extrusions and some bolt together pieces and a couple of linear rails. And through this iteration process and this speed of manufacturing process that we teach, they were able to progress from one prototype all the way to the Form 1 that they eventually launched and was the bedrock that turned them into an amazing 3D printer company that everybody that does 3D printing knows. That was about a year. So they went through, they created their first deliverable 3D printer in about a year's time working with us in Shenzhen. So another great company that is relatively new is Cocoon Carbon. So they basically take the waste product, which is slag from the steel making process, and they actually turn it into a cementitious additive, which allows them to reduce the amount of Portland cement that you need to actually make concrete. So and the way they do that is they actually take the slag and they melt it, and then they atomize it in a special rig that we designed. So this is just a screenshot from our team in Pune of like the first prototype that they did. Then they actually built it in Pune. They built a small version, and then they shipped it to us. And normally this is where I'd have a video, but I cut it for time. And it's kind of funny, when they came to Hacks, they had a barrel and a pressure washer. 6 months later, they have a fully developed prototype that now they just closed, about a year ago, they just closed a $5.4 million round, and now they're actually in a steelmaking plant. They're actually doing full-scale slag recovery and melts, which is amazing. Another one that some of you might know is PCM, Princeton Critical Minerals. They're basically boosting lithium extraction from salt brine. And really, this is a great one for this early prototyping strategy that we taught. They have these things called lily pads, which are about 1 meter in diameter, and they float just below the surface of the water. And they've got the lily pads to float below the water really easily, but the problem is they float them out into this giant lake that's about, 200 yards to the left and 400 yards that way. And there's about 40,000 of them floating out there. And the problem is every single one of those has to be recovered, has to be washed, and has to be put in at a very specific way to make sure there's no air bubbles underneath it. So from a very early stage, we actually started over here with just a plastic bin and a bunch of little 3D printed discs that we actually used from, if anyone has bought a Bamboo Lab printer, you know that they will send you the little discs that are the samples for all of the colors that they make. And we actually just cut the string, laid them out in the pool, laid them out in the little tray, and then we created what they now use in the next slide you'll see is a series of booms that collect up all of them. They're kind of like oil booms, but they have a special net underneath them to catch it. So we created that prototype out of packing tape, foam darts, and 3D printer samples. And that took about 5 minutes to do. And we prototyped it, made the first one in 5 minutes, and then we spent the better part of an afternoon refining and cutting the tape, putting more foam darts on it, and eventually ended up with a system that's now currently deployed in their facility down in Chile, where they've got they just shipped the new version down. And the other one that we did was the entry point. It has to have a specific little bump to it. So we just machined up some aluminum discs that were to scale, the right size, and then we just soldered together some brass and some soft wire to actually see how it moves up and down. And that eventually, after another 2 or 3 revisions, turned into the final system that you see. And that's basically the booms that you see and the inserter that you see over there. And that whole time from the first prototypes to this was about 2 months. And between that, we actually got in trouble with the building because in order to do some small scale testing, I had to build a swimming pool on the 10th floor of our building. They were not happy about that. But we made we can get away with stuff like that because we work with the startups. The startups are a voracious, energetic, amazingly driven group of people, and they want to move fast at all costs. And it's really inspiring to see how they tackle their problems on a daily basis. Because every 6 months, I get 15 new companies that come into our office. They're 15 companies that could be from 15 different industries, 15 different 15 different work styles, 15 different personalities, and we have to work with them. So the way we like to think of ourselves is we are specialized generalists. We're specialized in the fact that we know how to accelerate hard tech with great speed, but we're generalists in the fact that we have to learn as much or more than our startups do, because we have to be able to have intelligent conversations with them. We have to know the technology that they are developing and designing and the industries that they work in. So we're learning just as much as the startups are, and it's a constant learning curve. It's high pressure, and it's a lot of fun. So thank you so much. What are your questions? Go for it.
What's the financial obligation for the startups to tackle?
Yeah, so our standard, we have a standard deal where it's about. Oh yeah, there we go. There's a microphone. Can you repeat the question?
What is the financial obligation for a startup company to Hacks?
Yeah, so our financial obligation to them is basically we take a percentage ownership in the company. It ranges from 11 to 14%, depending on our deal, and the standard deal is 11 to 14% for $250,000 worth of investment. And that's split between a program fee that comes directly to us, and then $150,000 of that is what we use to value the shares of the company. And we also put in the option of doing follow-on investment when they raise their next round, and we pretty much always use a safe at the first out. Yes.
Hi, I don't know if you mentioned this earlier, but how did you get your start in Hacks?
Oh no, I didn't even say that. That's kind of funny. So it's a perfect story for the Makerspace. A man by the name of Will Lutz, he used to work at NJIT, and he used to come to the Makerspace all the time. NJIT is the Innovation Institute that NJIT runs. And he was very good friends with my boss, Sean O'Sullivan. And Sean O'Sullivan was saying, hey, we need somebody to help us build and run a prototyping facility in Newark. Who do you know? And Will basically said, oh, I know this guy, Joe. He works at the Makerspace that I go to at school. Talk to him. And then they were actually trying to potentially recruit some of the other people that worked in and around the Makerspace, but it seems that I won out. But no, it was kind of fortuitous. I was finishing up my senior year here, and I was potentially going to get an offer from another research organization to kind of do the same thing for them, build a research facility for them as well. But Hacks won out because of the innovation and the newness of all the companies. It's, there's never a dull day at work. Who's next?
Do you have a certain criteria that startups have to work with or fit in order to accept them as a client?
So we really only deal with hard tech companies. So people that are producing physical products. We don't really do SaaS companies or software companies. And when it comes down to how we pick our startups, it genuinely comes down to about 50 to 60% of the decision is on the founders themselves and on the founding team. If the founders themselves work well, if they understand what the problems that they face are, if they can articulate that, and if we think that we can coach them, then they make a very good candidate for coming into our program. The other half of it is what's the addressable market that they're doing, what's the technology that they can produce, what is there precedent that they're working with in terms of, are there other players in the space? So it's a lot of factors that come down to it, but a large majority of the decision rests on who the founders are and how they work as a team. We usually try not to do solo founders. We like to see, one to two, at least 1 to 2 co-founders. So a founding team of 3, a founding team of 2 to 3 in order to come into the program. But again, it's not a hard and fast rule.
Yeah, do you guys ever generate new intellectual property after the company moves in the course of problem solving and you're helping them problem solve something? How do you guys handle that?
We do not control any of the company's intellectual property. So if the company, we've had companies come in that came in with some IP, and through the course of working with us, they found a much better version of it, and they patented that. We completely gave it to them, and we have no ownership over that IP. So they keep it, and it's in their best interest to hold on to that IP. We don't see the need in it because all of our returns come off of their success.
Do you ever find that you need to throw your name in as an inventor, even if all the IP gets assigned to the company?
No, I don't think we ever really put our name down as the inventors. It's always the startup founders. Yes. Where's the microphone hiding at?
I was gonna go.
Oh, so,
Did you have software knowledge, like a lot of software knowledge when getting this job, or was it mostly tangible, like Makerspace, that stuff?
I had next to no software knowledge when I started working here. I had to learn very quickly. I had to learn a lot of programming because I came in really as a builder. I came in as somebody who makes with his hands. I might have worked with Arduino a little bit beforehand, but I had to learn a lot. And thankfully, we had a electrical engineer that was able to teach me a lot in the early stages of while I was there. And since then, he's taken over more of the electrical side of it and more of the programming side of it. But he had to get me up to the point where we could have intelligent conversations. And now we do. Don't ask me to, write a lot of software. I can write some basic software for some of the basic systems that we work with, but having that bedrock basic knowledge is almost a requirement to work in the tech space. Was
Sorry.
there? Yeah, you go
Can I have a follow-up? How do you recommend you get that knowledge as a student?
As a student, honestly, working in the Makerspace definitely has a lot of benefits because there's great electronics labs that are here. Honestly, the way that I learned the most was through YouTube. It's kind of cheesy, but I learned a lot of the basics through YouTube, and it's because at the early stage that we're working with, a lot of the startups aren't writing a lot of their own software. Honestly, they're using ChatGPT a lot more than I expected to do the bulk of the writing and then debugging it afterwards. But since at the early stage, everything's changing so quickly, writing very basic code and writing very basic commands is really all that's needed because the designs are constantly changing, the footprints are changing, the microcomputers that they're using are constantly changing. So having the ability to understand the basics and apply it is really the most important thing that you need. Unless you're a software company, then you need to know how to program. Yes.
You seem to place a lot of emphasis and really highlight your guys' like metal work and that sort of thing, like simpler parts, not simpler, but like metal parts. Do you guys work at all with like electronics or PCBs or anything of that sort of nature?
Yes, we do. We have a full-time electrical engineer and a full-time PCB designer that we work with. Both of them are on our staff, and they're both in, one of them's in Newark, the other one is in Shenzhen. Basically, he's able to go to the factories, get the boards made, and then mail them to us. It's kind of crazy. He told me once that the province that he works in, he can, at 9 a.m., he can go to the factory with a board design, get a board by 11, solder it, give it to somebody else, solder it, and populate the board, test it at 11, and then keep doing that cycle. He can basically, he told me he went through a basic board, 5 designs in one day, fully populating it, fully designing it, and manufacturing it over and over and over again in one day. I'm like, that is insanity. But the companies themselves work with him on, obviously not that fast, but on some more complex boards, slower over time, but it's that similar process. We have electronics facilities at our space. We have, reflow ovens. We're actually just getting a pick and place, which is pretty cool. And the companies are always buying components and soldering them together. The most important thing that we tell companies at an early stage is try not to build everything from scratch. Focus on the core of your technology. Focus on that. That's where you should spend the most of your time innovating. You don't need to innovate a new power supply. You don't need to innovate a new way of, translating something with bearings. You don't need to design new bearings. Just buy the components that already exist, because when you take it to the point where you're going from making 1 or 2 prototypes to manufacturing thousands of them, a contract manufacturer is going to say, I'm not doing that, I'm just using the one bearing that I have 50,000 of in my warehouse. So putting that idea of using simple things, not necessarily designing your own boards or components early on, is really helpful when companies get to that scale-up point. Yes.
Yes, very nice talk.
Thank you.
And I'm curious about, you mentioned that you're going to talk with more than maybe 16 clients or company a day. How can you get yourself ready for that?
I have a halfway decent memory, but my calendar book tells me most of what I need to do. The one thing that I will say is, since I have, at any one time, we've got about 20 companies in our space, you get to see them constantly. You see them every day, and if you're not necessarily actively working with them, you're hearing things from other people. You're constantly being kept up to date on it. And if you looked at my inbox, you would probably run screaming, because I have probably 400, 500 emails a day from all these different manufacturers and the startups. So unfortunately, about an hour of my day is just going through my emails. But I find that keeping notes constantly is really important. I always have, at any one time, at least 2 notebooks with me. They're over in my bag right now. But always have them, always take physical notes. I find that, texting on my phone is fine, but I'm faster at writing. And I actually think better while writing, because you can do sketches and doodles with it. But constantly checking in with the companies is really important. And even if I'm not actively working with them, I'm always reading up on what they're doing, checking in with my other colleagues, and just trying to stay abreast of what's happening, because it happens so fast.
Yeah, so another question is about, in your slides, you mentioned that like nowadays the software alone is not going to solve the biggest problem that we have today. What do you think, like any ability relevant about the software that we should have to get ourselves ready for the future work?
Yeah, so software, don't get me wrong, software is just as important as hard tech, and hard tech could not exist without software. That being said, hard tech is much harder to do because of the capital investment that's needed. But in terms of software, having an understanding of mechanical design and implementation of the software, so you can speak intelligently to the mechanical engineers, to the industrial engineers that are designing the parts that your software will work with. Having that base level understanding is almost like gold in a manufacturing and startup world, because if you don't have it, you're gonna find that you get underwater in the job pretty quickly. So not only understanding how to write the software, but understanding how it's implemented and how it's used, and even how the system works, not just from I need to send this input and get this return, from I send this input, what does it do? What does it do in the real world? How will it affect it? That will make you a better marketable programmer to startups and to companies in general, because you can speak intelligently about not only how the code works, but how the machine uses the code.
Thank you so much.
Thank you, Joe, for coming here and giving us a great speech. And I really liked your presentation. My question for you is, what stage do you want the founders to be at when they apply? And how much of a role does a minimum viable product play in when you guys are looking at that team?
So we've invested in companies that have a beautiful MVP that looks like it could be showroom ready and roll it out and start selling it. We've also invested in companies that have some really good university research, have some good understanding of design, and maybe have a few pieces of example that they've worked with, like maybe a couple of 3D prints. It really comes down to the founder's ability to convey that what they've designed or what their company is it a problem? How are they solving it, and how big of a problem is it? And if you can address all three of those, and you're a founder that's coachable, that can take some guidance, take some criticism, because we have to criticize some of our startups sometimes, because they every founder is like, this is the perfect thing ever, but it's you have to be able to take some a little bit of understanding, and also be able to educate us on their product and on their market, because sometimes we invest in things that we might not be super familiar with, and if you as a founder can articulate to us why we should invest in you, and not only have the numbers to back it up, but get us excited about it, sky's the limit.
Hey, hi.
Oh, all the way in the back.
By the way, great presentation.
Oh,
nice
thank
to
you.
meet you. What's your take on environmental startups and environmental startups?
Environmental startups?
Yeah.
That's all that we do. All of our startups have to be either carbon neutral or carbon negative, and they all have to be, some people think, oh, we're a venture capital firm. We're evil henchmen in, what are they? I don't even know what they are. The, quarter zips or sweater vests. No, we actually care about the environment, and we're nice people. But we love environmental startups. It could be a product that is actively trying to sequester carbon. It could be a product or a service that is augmenting an existing process that's better for the earth, better for the environment as a whole. Or it could be some new material that is being created, like cocoon carbon, a new material that's coming from an existing waste stream. So we say we get about 10,000 applications a year, and we only accept 30 at any one time. So it's a lot. So we've seen a whole bunch of different startups that come through the door, and it's genuinely really hard to narrow it down to 30 a year. So we've invested in just about everything.
So does your company invest in any kind of what do you call ideas which has proof of concept in environmental sector?
Usually it has to, we do invest in ideas, but there has to be a business that can come from it. We don't usually, we don't invest in purely research, but if research from a university has some commercial viability and has an addressable market that we can see and actually addresses a real problem in the world, we invest in that all the time.
Thanks.
Awesome. I think we got some questions up front.
If one of the biggest hurdles for startups is an inability to purchase the machines needed to build their products, do you know how Hacks was able to purchase those machines when it was starting out?
So there's a story. So SOSV stands for Sean O'Sullivan Ventures. So Sean O'Sullivan is the founder and managing general partner of our firm, and he was lucky enough and amazing. He has an amazing story, which I won't attempt to tell because he's so complicated. But he had an amazing couple of exits from early software that he developed and early companies that he was a part of. And he put up the initial $25 million to start the fund back in oh geez, you're gonna make me do math now. I think it was 2002 he got his start. And then since then, every 5 years we raise a fund. So we get our LPs, they come to us, they see the program we run, the companies we invest, and the money we return to them. And then they choose to invest in us. Like I said earlier, we just closed a $306 million round last year. Essentially, we're just a big startup. We're a big startup that helps other younger startups. So it's in our best interest to help the startups do better, because we do better, which allows us to raise a fund and lets us stay in business. So we are a startup, just 1 or 2 steps down the line from the ones that we invest in to start off. Down over
I
here.
got a question. Hey, so what is the iterative process like for you guys as a team when you reach a consensus and like we're doing this and this is the product we want to manufacture?
So like when we choose to invest in a company?
When you're in the design process, which like you showed, when you guys choose to like stop at a certain point and like move into development?
We never stop iterating. We get to a point where we're like, okay, we need to pause the iteration, make a version of it, test it, and then go back. We never stop iterating. All of the companies, like the companies that you saw that had the big water blocks, we've iterated past that 2 more times. Even though between the first one and the one that was over here, it had a 6x increase in its thermal efficiency, we have continued to push it. Now, there's a certain point when you need to go more into the manufacturing side of it, where you have to design for scale up and not necessarily design for small scale. But that's the same process. You identified the problem. The part that we made might not be perfectly scalable for, it's perfectly fine for a 10, 20, 50 piece order, but now I need to scale up to 20,000 pieces. That's a totally different method of thinking. And it's the same thing. You're just back at the start of that iteration process. So you design it, iterate it, you work with the manufacturer to help you with that, and then you go back again, and you constantly keep working on that. Innovation and iteration never stops in the startup world, and it's a constant process, and everyone's always changing as they go.
I have 2 questions, if you don't mind. So what kind of time is expected for these teams to be spending at Hacks? Like, for example, are people living off of their savings and investing all their time here? Or do they also have full-time jobs on the side?
No, usually what happens is when we make an investment, there's an understanding that this is your full-time employment. This is your full-time job because we are giving you a large amount of capital. We're providing you a lot of in-kind space and a lot of in-kind money to actually do your work. And the startups that succeed the best are the ones that take the most advantage of the space. We don't encourage it and we discourage it, but some startups do bring cots and they sleep next to their desks or sleep in the presentation rooms so that way they can get up after a 3-hour nap and get back to work. I did have to put some controls on all the CNC machines and all the machines to turn them off when I'm not there because we don't want them hurting themselves, especially in a sleep-deprived state. But I've had to go back to the office a couple times at like 9 o'clock at night, and I still see startup founders working there. And the ones that work the hardest usually are the ones that succeed the most and raise the most money. And what was your second question?
And then just to clarify on what you said before, pretty much anything, like anybody that would be approved to come to Hacks, the startup has to be like very environmentally focused. Like if, say, I wanted to make a tripod or something, that would just be denied.
No, I wouldn't say it would be denied. It would be something that we'd have to look at and see, is there a great market for creating a new tripod? What's the innovation that you're doing there? Why is your tripod better than everybody else's? And how are you going to capture a large portion of the market and basically drive out other people and return us the investment that we make in you and the follow-on investments that we make?
When it comes to the brunt of the innovation that is done, how much of it falls, like, is the engineering team at Hacks working with the founders versus it's primarily on the founders and you guys are just there for the manufacturing side?
It's both. It's interesting. We tailor the program and the way that we interact with the companies to the company specifically. So I'll take you through an example. When we have a new startup come into our space, as an engineering team, we'll sit down with them for a 3-hour meeting and we say, tell us everything. Tell us who you guys are, what your level of understanding and knowledge is, what are the key stumble blocks that you guys have, what are the problems that we have to solve, where's the tech right now, and where do you want to go? And then depending on the result of that meeting, some companies have an amazing engineering team, deep technical knowledge, and we just act purely as a source of connections and assistance from an industry standpoint. Other companies come in and they're much more business focused. They understand the market, they understand exactly who their customers are, and they understand how they're going to sell it, but they may lack some of that deep engineering technical expertise. That's where we step in more as kind of like a contract engineering firm for them. We have one guy, one of our engineers in our office, we lovingly call him the engineer for hire. So he goes from company to company and spends like 2 months deeply ingrained with them, and to help push them over the line in terms of a large milestone or a large project that they're working on. But not every company needs that. A lot of companies, come to Newark, and they come. A funny story. One of my favorite companies, Silana, they came from Austria. It was literally 2 guys and a suitcase, and in the suitcase was a 6-axis robot arm that they came over from Austria. They came over and they said, oh, we're only going to spend 3-6 months here, and then we're going to go back to Austria. That's where our team is. A year and a half later, the team is now 23. They moved into downtown Manhattan. They're in the garment district, and they're actually looking for a workshop manager to run their facility. So in a year and a half working with us and working in our innovation space, they've completely forgotten about Austria, and they want to stay here in the United States and do it. But like we said, we tailor the program to the company where they're at.
Thank you.
Was there another question over here? I think there was some. Oh, over there.
The process for a startup to be associated with hacks, do they pitch the idea to the businessman at the company, and is there an engineer also sitting in the discussions, or how does it work?
So usually the way it works is if you have an idea for a business or you have an existing product that you want to potentially apply to our program, you'll reach out to us through our online application, or you'll meet one of the staff members, and then we will take your information, your deck, your presentation, and then send it to our IC, so our investment committee. They will then schedule some meetings, they'll do some due diligence, and then all throughout that process, the IC is talking to the engineering staff. I get decks every day from startups that come in, and the investment committee is like, hey, what do you think of this? Is this company worth it? What are the technical headwinds that they're going to go up against? What are questions that we should ask them? So, and about half of the people, actually no, 3/4 of the people on the investment committee are professional engineers. So we have a lot of professional engineers that are on the board that actually chooses who we invest in. So there's a deep technical knowledge already there, as well as a business knowledge. So they understand both sides of the coin.
And like the more capable or qualified a startup is, I'm guessing they'll get further along in the application process, whereas one that doesn't sound good, you maybe stop it in the beginning steps?
Yeah, I mean, we get about 10,000 applications a year, and we have to narrow it down to 30. We can't have, the usual cadence is there's like 3 or 4 meetings that you'll go through. We can't do 40,000 meetings with 4 people over the course of a year. They would do nothing else, not sleep or anything. So some of the early stage companies, some of the ones that get knocked out of contention early, it's because their deck wasn't good, the product market fit wasn't there, the total addressable market isn't what we are expecting or at a level that we would invest in. So really getting those numbers down, getting that information right in your marketing material, so that way if I look at it and I have like 30 seconds to look at it, you need to make sure that in that 30 seconds I'm impressed and it wants me to reach out and do another phone call or do another Zoom call. What's up, Danny? I got here late, sorry. Could you do your whole presentation? Sure. How much time we got? You look great. Thank you.
So kind of a follow-up question to the deck you were just talking about. Have you ever dismissed something out of hand because of excessive AI involvement in the preparation of a deck?
That is one thing that we are now looking a lot more at. We're seeing a lot more decks that come in that are AI assisted. The thing is, we can tell if the deck is kind of done with AI, but at the same token, we're not really critiquing how they made the deck. We're really critiquing what the substance of it is. So a company might get through, on some little, they might sneak a little bit of AI into it, But once we have that first meeting and we start asking the real questions of the breathing human being, we can pick up pretty quickly on if the company itself matches what the documentation says. But we fully embrace AI at the office. So I won't confirm how many emails I've sent through it and just rewritten because it sounds better. But a lot of companies use it, and we have a couple of companies that are built exclusively around it. So it's really something that we've embraced because it's the technology boom that's happening right now. Any other questions? Oh,
me.
there we go.
From what I've gathered, I guess like a lot of the companies, I guess investment in itself is like in the people that it hires.
I'm sorry, say that again?
In the people that it hires, like a lot of the investment in the companies is in the people that it hires. How do you guys like future-proof, I guess, like in terms of like mentorship or like who you guys look to in terms of like future hires? Because I know that a lot of it is like specifics, like you talk about like hiring specific engineers or like people like that, whereas like you were kind of like an all-in-one that seeks to like talk to other, I guess, industrial designers or like different kinds of majors. Is there like a criteria that you guys look for? Is there like certain like spaces that you guys like look to be in to like kind of like garner more of the same kind of people?
I have a feeling that you're asking if we can come and say hi to the ID program.
Yes.
Of course. But no, honestly, we try to hold internship fairs and job fairs about once or twice a year in our space. And I think we're connected with the business school. And when those come up, we always welcome any of the local talent, any of the local students just getting out of college, or really anybody in the local area that's interested to come and meet the startups, meet us, and see what we're about. And one of the things that is really exciting is that you can work in the startup world even if you're not an engineer, even if you're not a business major. All of the startups that we have physical components to them. They have to actually be made. And at the early stages that they're working in, there's a lot of people that don't exactly have the skills to actually design or make something with their real hands. And that is something that is really tangible, because when you have a billionaire investor that walks up to your table and all you have is a couple of pamphlets, if you have a widget or something that you can put in their hand and say, this is what our company does, this is a component of what we do, and speak eloquently about it and intelligently, that's the world to them. That could be the difference between a second call and a potential walk away and not making an investment. So the physical ability is something that is really sought after, but it can be trained of the founders. And I do a lot of hands-on training workshops with the founders when they come to our space, and we do I do a lot of presentations. One of my favorite ones to do is it's called How Not to Piss Off Your Machinist, because I can't tell you how many times people send me files that have radiuses of like 3 thou, and I'm like, how do I get a tool to cut that? And it's at that early stage, especially in the startup world, understanding how manufacturing is actually done, how you're actually going to make your parts and pieces, is invaluable. It will not only, the sooner you can design with an eye for manufacturing, the sooner and more, the deeper you're going to go in terms of your product development. You're going to encounter less headwinds, less redesigns. So really a deep understanding of how stuff is actually made is critical.
What would you say are the most common constraints, or
say it again?
What would you say are the most common constraints that you work with these startups, or obstacles that come up?
Ooh, that's a good one. A lot of them are constrained by money and time. So we can't always make the part the best. We can't always make it the most precise. A lot of them need it quickly, and the speed at which innovation has to happen is much faster than industry. In an industrial setting, getting a part made in a month is considered fast in some cases. But if you wait a month and then you have to test it and then make it again, it takes another month. That's a third of a company's runway. So that ability to design for fast manufacturing and rapid manufacturing so you can secure the next round of funding is really something that a lot of engineers coming just out of university have to understand. It's understanding that you have to design for speed in the startup world. Not everything has to be 100% perfect, but you have to get the critical dimensions, the critical pieces done correctly, so that way you can test it and iterate on it. And that's getting people to move fast enough is really probably the biggest constraint in terms of that, because the money is finite. Money runs out, and if you don't have a product when you run out of the money to get that next round of funding, the company's dead. It depends. It depends on the founder. It depends on the product. You know, some products can be made by hand on a manual milling machine or a manual lathe, and those can be done in hours. Some of them are required to be made on a CNC. Some of them are required to be made on CNCs that we don't have in-house and we have to send out for them. So the companies that benefit the most are the ones that can design within the machines and tools that we have, or accept the lead times that you have to get from industry. Yes?
So I know you guys work with a lot of different kinds of founders and whatnot, and I'm just a little curious, like, how old are most of them, what are their backgrounds, and what characteristics do all the successful startup founders share?
So a lot of our founders are on the younger side. So most of them are under the age of 35. A lot of them are coming right out of, you know, PhDs and postdoc programs. We have a couple of master's degree holders that are running companies, and a willingness to be scrappy and move fast and constantly learn is really something that's sought after. You know, the ability to, you know, take input from our investment committee and from our design committee and our engineering team, implement those designs and iterate on it, and not be hurt by it, not be hurt like, oh, well, this thing doesn't work, what am I going to do? The ability to shrug that off and keep moving is really something that is sought after. And really an openness to learning is really something that we look for. And really, if you know your stuff, whether it be the business side of it, whether you know your engineering down cold, and you can convey that in a manner that anybody can understand, that's the whole shooting match right there.
Thank you.
Any other questions? Any more? No? All right. Well, I think that's it. I think Dan's going to say something, maybe?
Just want to give Joe a big round of applause.
Thank you.
And then one little housekeeping thing. So if you guys are not aware, NJIT has launched a micro-credentialing platform. We're participating in that here in the Makerspace, and a bunch of other divisions on campus are doing that as well. So we'll have little micro-credentials you can earn here, and they'll combine to generate larger credentials. But one of the smallest ones is just attendance at an event, and we're going to put a QR code up on the screen. And if you came to this for a class, scan the QR code, fill out the form, and then we'll make sure you get issued that little micro-credential. All right?
Awesome. If anyone's interested, I have brought some of the prototypes that I'm able to bring that are not under NDA. You can look at them up here, and I have a handful of business cards if anyone's interested. Thanks so much.